2 agents, 1 job, split down the middle. Nothing crashed, nothing errored. Both halves came back finished, and they did not fit together. Each had assumed something about the other, and neither assumption was written down. That is the failure that decides whether you run 1 agent or 10, and almost nobody catches it because it does not look like one. It looks like a merge that compiles. There is a test that tells you in advance whether a job can be split. It is 3 questions long, and most people never run it because they start from a question that has no answer. Not how many agents, what can be handed out, and what exactly one thing has to keep. 3 different things get bundled under the words multi-agent, and they do not cost the same. The first is a helper. 1 agent opens a second window, hands it a scoped job, and gets a summary back. Settled, and this season covered it as isolate, 1 of 4 moves on a context budget. The second is a team. Several full agents, each with its own window, sharing a task list and messaging each other. The third is a swarm. Many agents, no owner of the outcome, coordination meant to emerge. All 3 trade the same way. Adding agents does not make the model any smarter. It buys 1 clean, uncontaminated window per agent and charges 1 more place where 2 agents can assume different things. So picture a contract on a table. Any number of people can read it at once. Exactly 1 signs it. Episode 1 of this season left a disagreement open, and both sides have since answered it. They answered it with the same condition. Start with the side that said no. In the middle of 2025, an agent company published a post arguing that most people should not build multi-agent systems. A tempting architecture, they wrote, and very fragile. The same author published a new post 10 months later. It opens with the words, 10 months ago, I wrote, don't build multi-agents. Nothing was withdrawn. The author himself says the original observations still hold today for parallel writer swarms. What changed size was the conclusion. A general warning became a specific rule. Multi-agent systems work best today, the new post says, when writes stay single-threaded, and the additional agents contribute intelligence rather than actions. Now the side that built one. In June of 2025, 1 day after that warning went up, a Frontier lab published how it had built a multi-agent research system. 7 months on, the same lab published a decision guide for this choice, and it lands on the same condition from the other direction. Work should only be split, it says, when context can be truly isolated. And it marks the split almost every team tries first as often counterproductive, dividing by type of work. 1 agent writes the feature, a second writes the tests, a third reviews the code. That creates constant coordination overhead, because those are not 3 jobs. They are 3 views of 1 job meeting the same context. 2 companies, opposite starting points, 1 condition. Split only where the pieces never have to agree. Where they differ is worth your attention. The lab will let separate components with clean interfaces be built side by side. The agent company keeps every write on 1 thread. So what does the extra agent actually buy? Not more brain. A clean window. The reason, in the revised post's own words, is that a clean context makes the agent smarter because of the math of attention. That mechanism has its own episode here. The decision guide gives 3 legitimate reasons to split: protecting context, exploring more paths at once, and giving each agent fewer tools. And the sharpest case is a code reviewer. Its value is not being smarter than the coder. It is never having read the draft, so it cannot inherit those assumptions. That company reports 2 bugs caught per pull request on average, even on code. Its own agent wrote, roughly 58% of them severe. That is a vendor number about its own product, with no methodology published. So what does it charge? Not money first. Actions carry implicit decisions. That line is from the 2025 post, and it survived the revision. When an agent acts, it commits to things nobody wrote down. What it gets called, how it is structured, what happens in the awkward case. A second agent in its own window commits to different ones. In that post's description, neither could see what the other was doing, so the work came back inconsistent. Picture 2 builders told to meet in the middle of a staircase. Both halves are perfectly level. They meet at different heights. We have an episode on agents failing over long tasks, where errors compound. This is the other kind. 2 failures at the same instant, each one locally correct. Now the tokens, where numbers get misread most. 1 company has published 3 multipliers, each measuring a different thing. Their research post says about 15 times more tokens than a chat, and the denominator there is chat, not 1 agent doing the same job. Their decision guide says 3 to 10 times a single agent on equivalent tasks, the comparison a builder actually faces. Their coding tool says roughly 7 times a standard session, and only when teammates run in plan mode. 1 company, 3 price tags, each weighing a different bag. That post is also the source of the number you have heard, a research system beating that company's best single agent by about 90% on 1 internal evaluation of research work, which the same post calls a better fit than coding. And then the line underneath. On their own browsing evaluation, token usage by itself explained 80% of the variance, not the agent count, the spend. So a large part of what a team of agents buys is permission to spend more tokens, which raises the question nobody ran. Compared to what? In June, an unreviewed preprint ran that control group properly. It took multi-agent systems, whose structure was generated automatically by design methods that search for the arrangement instead of a person choosing it, and put them against 1 agent run several times with a majority vote. The automatic systems lost consistently while costing up to 10 times more. Now the half that keeps getting dropped. On a test, the authors built to give multi-agent systems their best case. Expert design systems consistently beat the generated ones, on raw performance and on cost. So the finding is not that multi-agent fails. It is that the design was doing the work all along, and what the generated systems produced was architectural bloat. There is now a way to say in advance when splitting helps. An unreviewed preprint from July frames the question as bandwidth. One agent keeps the entire reasoning context. A team squeezes that context into short messages, so any advantage exists only because those messages are narrow. Their result is a condition. It helps when the handoff carries nearly everything the next agent needed, and it helps weaker models most. It shrinks or reverses when the handoff loses information, worst of all for the strongest models. So it gets harder as models get better, which is the opposite of what most roadmaps assume. One paper, not a settled result, and where fresh evidence points the other way, it fits the same condition. In a second unreviewed preprint, a system built to hand each agent genuinely different evidence beat the strongest single-agent and multi-agent baselines by 12 to 18% on forecast error. So invest in a handoff, not the headcount. Then look at what shipped, because a product limit is an opinion with teeth. One lab's hosted orchestration reached public beta in May. A coordinator may list at most 20 distinct agents, and at most 25 threads run at once. And a coordinator can delegate one level down and no further, point it at an agent with a roster of its own, and the request fails validation. A manager may hire. The hires may not hire. In the same company's coding tool, agent teams are experimental, off by default, and teammates cannot spawn teammates. And the documentation says when not to use the feature it sells. For sequential tasks, same file edits, or work with many dependencies, a single session or sub-agents are more effective. Under it, the plainest sentence in the field. Two teammates editing the same file leads to overwrites. Nobody shipped the version with no owner. So run the test. Before the first question, one framework's documentation asks a blunter one. If you can write a function to handle the task, do that instead of using an AI agent. Say you still need agents. First question. Can the work be split into pieces that mostly read? Looking parallelizes, because looking changes nothing, and most multi-agent setups today are limited to helpers that only read. Second question. Does each piece truly isolate its context? Not stages of one job, and not different kinds of work on the same thing. If two pieces have to agree about anything while they run, they are one piece. Third question. Does exactly one thing hold the pen on any one document? One writer per contract. Everybody else reads and reports back. And one more, a helper must be able to check the work without the whole context. Fail any of these, and the answer is one agent with helpers that only read. So carry the shape. Adding agents does not make the model any smarter. It buys clean windows and charges coordination, and the rate is one asymmetry. You can parallelize the looking. You cannot parallelize the deciding. The question was never how many agents, it is how many pens. The decision guide puts this whole episode in one sentence. Start with the simplest approach that works and add complexity only when evidence supports it. Scope the specifics to the middle of 2026 because the limits will move. The asymmetry is the part built to last. This is episode 4 of Put AI to Work, our season on getting real work out of AI agents, one working skill per episode. The full free AI course is on the channel. Subscribe, and the next time somebody shows you a diagram of agents, count the pens.